Welcome everyone. I'm Uma Maheshwari, AP Triple Department, RMT Engineering College. This session, I'm going to discuss about the subject Power Electronics. Subject code is EE8552 and the unit of discussion is Unit 3 DC-DC Chopper. In DC-DC Chopper, we are going to discuss about step-up chopper. So step-up previous video, I have discussed about step down chopper. Now this session is about step up chopper. So step up chopper, we all we know that the output voltage is greater than the input voltage. Such a chopper operation is known as step up chopper. So in step up chopper, we will see the working mode of operation. So this is a step-up chopper. So step-up chopper circuit. So here in this chopper circuit, the positive is connected to the inductance and the chopper is connected in this inverted manner across the source, and there is a diode connected to the circuit and the capacitor C which is connected across the load. The output voltage across the load is represented by E naught. It is a V naught plus positive here, negative here, and the output current through the load is represented by I naught. The output current in the load is represented by I naught. I represents the source current, and the switch we have selected here is an SCR as a chopper switch. Now we will see the mode of operation of this circuit. So first mode of operation or mode 1 operation. So in this mode 1 operation, we will switch on the device chopper, that is gate impulse is given to the thyristor SCR and it is already forward biased. So here you can see the positive connected to the thyristor anode and the negative connected to the thyristor cathode. The thyristor is already forward biased and the gate impulse is given to the thyristor. So the thyristor is in on state now. So during the on state, the L stores energy. So during this on state, from the positive, the current flows through the inductance. So entering point plus and leaving point minus through the switch and through the and to the negative of the supply. So the flow of current IS is given by this direction, source current, and because of this polarity of the inductor, the diode is in reverse bias condition. So there is here you can see that during the on-state condition of the switch, there is no power flow from the source to the load. The L stores energy during this period. So here, this is when we discuss about the waveform. This here Vs represents the supply voltage, which is constant, which is equal to Vs, represented as magnitude Vs. And about the source current. The source current is nothing but the inductor current. It is the series. The source is connected in series with the inductor. So here, the inductor current increases I1 to I2. So when the switch is in on condition, the current flows from the source through the inductance, through the switch and to the negative. So the inductance gets charged during this interval. The charging current is from I1 to I2, and the change in current from this change in current is represented from I2 to I1 is represented as del I. So this is happening during the on period of the switch, and during the on period of the switch, the output voltage is 0 because this diode is reverse biased. It acts as an open switch. There is no power flow from the source to the load. So the output voltage is 0 and hence the output current is 0. This is during the on period of the switch. And the next mode of operation or mode 2 operation, when the switch is turned off, that is the gating pulse to the thyristor is removed. So it acts as an open circuit. So due to the sudden reversal of the switch condition, the polarity of the inductor is reversing from mode 1 to mode 2. Here you can see that the polarity of the inductor is positive here and negative here. When the switch is moved to off state instantaneously, what happens? The polarity of the inductor changes. Positive towards the anode of the diode and negative is connected to the supply. So because of this polarity of the inductor and added with the polarity of the supply voltage, the diode gets forward biased. So how will be the current flow here? The current is flowing from the source and through the inductor diode and through the load and to the negative of the supply. So here what is happening? The source voltage plus the energy storage in the inductor is given as the input to the load. So the load voltage is greater than the supply voltage. So such a chopper is known as step up chopper. So here you can see the output current I naught and the output voltage across the load is represented as V naught. So output voltage when the switch is in off condition is equal to the inductance voltage. Here you can see the waveform of the output voltage when the switch is in off condition. And how what will be the magnitude of the output voltage? It is the sum of supply voltage plus the inductance voltage VL. So here you can see the output current of VL, that is the output current I naught. So it will be same as that of the inductor current because they are in series, and you can see the inductor current, it is decreasing from I2 to I1 because energy storage in the inductance is given to the load. So the current reduces from I2 to I1, which is same as that of the output current. Current is reducing from I2 to I1. This is happening during the mode 2 interval, which is the off state condition of the switch. And after this mode interval, the repetition of the cycle takes place. Okay, so the T is the total time, T on plus T off. During on period of the switch, the output voltage is 0, output current is 0. And during the off period of the switch, the output voltage is the sum of supply voltage and the inductance voltage. And the output current, we are able to obtain it. So this is about the boost up chopper. Okay, or you can also convert as step up chopper, boost chopper or step up chopper. Circuit diagram and mode of operation of chopper and the voltage and current waveforms are discussed till now. Now we'll see the output voltage expression for boost chopper. Now, assuming the linear variation of the output current, the energy input to the inductor from the source during on period is, we are deriving the energy input to the inductor. So, V energy input, W input is equal to voltage across the inductor and the average current through L into the on period. Voltage across the inductor is same as that of the source voltage, and the current through the inductor is I1 plus I2 by 2. So here you can see that the current through the inductor, it is the I1 plus I2 by 2. The current through the inductor is increasing in this manner, I1 plus I2 by 2 into on period. And similarly, we will find during the off period, the energy released by the inductor to the load when the switch is in off state is nothing but W off. So voltage across the L, average current through the L into off period. So what is voltage across L during off period? So during off period, VL is equal to V output minus Vs. When you apply KVL to this closed circuit path, so when you apply KVL to this closed circuit path, we obtain the voltage as VL voltage as V output minus Vs. Apply KVL to this closed circuit path. So we are able to obtain VL as V output minus Vs, and the average current through the inductance is I1 plus I2 by 2 and into the off period. Now assuming lossless condition, the two energies are the same. So input energy is equal to the energy output. So we are equating the Vs into I1 plus I2 by 2 into T on is same as V output minus Vs into I1 plus I2 by 2 into T off. Cancel the common terms and multiply Vs into T on is equal to V naught into T off minus Vs into T off. Now what I require is V naught expression. So bring the V naught to the left hand side and take the other terms to the RHS. So V naught into T off is equal to Vs into T on. When this moves to the other side, you get minus. We cancel the minus term, so it is Vs into T on plus T off. T on and plus T off is nothing but total time T. So we are able to obtain the expression, it is Vs into T. So V output is equal to Vs into T by T on, which is equal to Vs into T by, the T off can also be written as T minus T on, because the total time is T plus T on. From that, if you require T off, it is T minus T on. So, and I take the T common out and cancel it, I get the expression as Vs is equal to 1 divided by 1 minus T on by T. What is T on by T? T on by T is nothing but alpha. Okay, alpha. T on by T is nothing but alpha. So when the switch is in off state, V output is equal to Vs. Whereas when the switch is in on state, when I substitute V as 1 in your output voltage expression, V output is equal to Vs. Vs by 1 minus D. When I substitute D as 1, I get the value of the output voltage as infinity. So we are able to understand that when we are varying the duty cycle, we are able to vary the output voltage. When the duty cycle is 0.5, the load voltage is 200%, which is greater than the input voltage. So in boost converter, the output voltage is greater than the input voltage. Thank you, everyone.